Hello everyone, in this video I want to tell you how the Routh Stability Criterion works. When you are actually solving problems, you would like to know the position of the roots and hence the stability of system without actually finding them. So how do you actually determine that a system is stable depending on the position? If you have the roots on the positive side of the S-plane, it means that the system is unstable. If you have a root on the imaginary axis, the system is said to be marginally stable. Well, this root shouldn't be there then. And if you have all the roots on the left half of the S-plane, the system is said to be stable. So depending on this, you can tell a system is stable, marginally stable, and unstable. So for this thing, you'll have to solve the equations, you'll have to find out what the roots are, and then decide if the system is stable or not. But how would it be if all that is not necessary and you can tell the stability of the system just by following a few simple steps? So Routh Stability Criterion is exactly about that. Now here I have a transfer function. T of s is equal to 5s squared plus 2s plus 1 by 3s cubed plus 4s squared plus 2s plus 3. So for this transfer function, the characteristic equation is the denominator. So this 3s cubed plus 4s squared plus 2s plus 3 is my characteristic equation. So solving that will give me the poles and hence will give me the stability of the system. So what if I can find out the stability without actually having to solve it? So this is what the Routh Stability Criterion does. Write down all the terms to the left. So write down all the terms to the left, like the powers, s cubed, s squared, s power 1, s power 0. And now write down 1 and leave this one and write the next one, leave this one and write the next one, however big it might be, for the first two terms. Now I have s cubed, so I'm gonna write 3, I'm gonna leave 4, and I'm gonna write 2, and I'm gonna leave 3 and I'm gonna write the next one if there is something, but there isn't anything, so I'm gonna write 3 and 2. In the next thing for s squared, I'm gonna write 4 and I'm gonna write 3, so 4 and 3. Now this is it. This is these first two rows you're gonna take from the characteristic equation, but for the other terms you're gonna derive them from these two rows. Now how am I gonna get this value? It's really simple. All you need to do is multiply these two, 4 into 2, which is 8. So 8 minus 3 into 3 is 9. By 4, whatever number is towards the most left. So you're gonna multiply this with 2, which is 8, and then you're gonna multiply 3 and 3, which is 9, and you're gonna write 8 minus 9 by 4. Now what is 8 minus 9? It's minus 1 by 4, which is minus 1 by 4 is minus 2.5. So let me write down as minus 0.25. I'm sorry. So that is 1. So when there is nothing written, you can assume that it is actually 0. So in the next row, when you're going to write something, this is 4, you're going to multiply this 4 with this 0. So 4 into 0 is 0, and you're going to multiply 3 and 0, so which is 0 again. I'm just going to write 0 here. So the next thing is multiplying this number and this number, which is 3 into minus 0.25, minus 0 into 4. By minus 0.25. Let me just write down, maybe it's not clear. So you're going to multiply this minus 0.25 into 3, this is one term, minus 4 into 0, which is 0, by, again, the leftmost thing, minus 0.25. So you're gonna cut off minus 0.25, and this is gonna be 3. So now I need you to look at the first column, which is 3, 4, minus 0.25, and 3. So the only way of telling is how many times is the sign getting changed. So if you look at 4, the next number is minus 0.25, which means there has been a sign change from a positive to a negative. So that is sign change 1. And there is another sign change between s power 1 and s power 0, because it has changed it from negative to a positive. So there are 2 times of sign change. So the Routh Stability Criterion explains that the number of sign changes is equal to the number of roots present in the right half of the S-plane. So what does that mean? It means that there are 2 roots of this equation in the right half of the plane, in the right half of the S-plane, which means you can call the system as unstable. So this is the first case of Routh Stability Criterion, and I'm gonna tell you 2 more cases. What are you gonna do if the first element is a 0? Because you'll be dividing the content with the leftmost element of a row, you cannot divide with 0. It can be determined. So there is a special case for 0 as the first element, and a special case if the whole row is 0. So for these 2 cases, there are 2 more videos named part 2 and part 3. And if you need to know those, just click on them. If this video has helped you, thank you. Hope you found it informative. And if you have an exam tomorrow, all the very best. Bye.